Hello, my name is Ayman Islam. Welcome to my ECE 5000 final project demo. My project was on the 4-light on-off system using the Mycroft software. We have the product brochure for the product Hey Mycroft. About this product. This product is a 4-light on-off system as previously stated, powered by a Raspberry Pi and Mycroft voice assistant. The installed microphone takes voice inputs from the user and sends them to the Pi. Based on the input, the Pi will send a signal to the relay connected to the lights, toggling the status of each bulb. The system is easy for all users and portable, only requiring an outlet and a voice. The product features. This product contains one Raspberry Pi 4 Model B. There are also 4 12-volt light bulbs, one 4-channel relay module, which is connected to each of the light bulbs, one external microphone, one 12-volt lead-acid battery, one soldered breadboard connecting the lights and the relay and the battery, and one battery charger to, of course, charge the battery once depleted. The battery specifications. The battery is 12 volts, 7.2 amp hours for 20 hours. The cycle use is 14.5 volts to 14.9 volts. The initial current is less than 2.88 amps. The standby use is 13.6 volts to 13.8 volts. The dimensions are 15 by 6.45 by 10 centimeters. It weighs 2.47 kilograms, and as said earlier, this is a lead-acid battery. A battery charger is also provided in case the battery is depleted, as you can see here, and this battery charger is also inside of the box. So, how the product works. As stated, this product is a 4-light on-off system powered by Raspberry Pi and Mycroft. The Pi inputs and outputs Mycroft skill voice commands, which are programmed onto the Pi using Python. These skill voice commands are the custom commands which can recognize patterns in speech and send signals. The system is programmed to individually turn on and off each light by saying the words, Hey Mycroft, turn light, and then you select your light, 1, 2, 3, or 4, and then you say on or off, depending on the behavior of the light. The pre-programmed system allows for seamless use for any customer. Connection details. The connection details for this product are quite simple. The external microphone connects to the Raspberry Pi, which is connected to the relay module. Each channel of the relay is connected to a separate light bulb. The light bulbs and relay are also connected to a soldered breadboard, which is connected to the internal 12-volt battery, meaning all connections are housed inside of the product and on one soldered breadboard. As for the exterior is hard plastic, completely coated in all black. All components are housed internally, besides the light and microphone, which are secured to the exterior, but are connected in the interior. A small hole can also be found in the side to insert the HDMI in case it needs to be popped up on a screen, and of course the power cord to power the whole system. The product is dimensioned at 35 by 20 by 12 centimeters. Pictures can be found here, and later in the video I will go through the entire product. And yeah. Here we have the block diagram of what my completed system should look like. Starting in the middle, we have the Raspberry Pi 4. As you can see, there's a power line coming out of the back. This will be plugged into an outlet to power the system. Connected to the Pi, we have the USB microphone. As you can see, this is on the left-hand side and protrudes out of the box. Connected to the Pi, we also have the 4 relay modules. One connection is for each input on the relay to flick each light on and off. We also have the 4 lights, 2 on each side, connected to the relay to the normally closed pin, meaning that when the relay is activated, this pin will open and the light will turn on. We also have these connected to the soldered breadboard. As you can see, the common of each relay is connected to the soldered breadboard, along with the power of each light. This is because the power from the battery and the ground from the battery are connected to this breadboard as well, meaning this breadboard, as long as the battery is connected, can supply power to the relay and the lights. Coming down here, we have the functional block diagram for the system. As you can see, first we have a microphone, which takes the user input, this microphone on the left. The user input is then processed on the Raspberry Pi, which has Mycroft installed and coded onto it, right here. And then the outputs from the Raspberry Pi go to the relay, which then control the 4 lights to turn them on and off. So basically, when Mycroft hears the custom skill, it will then tell the Raspberry Pi if custom skill is turn light 1 on, send a signal to channel 1 of the relay, which is connected directly from the I/O pin of the Pi, and once the signal is sent to the channel, the light will turn on or off. Here we have a flowchart for the code. So it starts, it asks user if they want to turn light 1, 2, 3, or 4 on and off. The voice is then recognized. If not, it'll go back to this stage. If it is, it then searches for on or off. If the light is already on, the light will then repeat. If it is off, then the light will turn on. The same goes for off. If the light is on, then the light will turn off. If the light is already off, then nothing will happen. This is repeated infinitely until the system is unplugged. I'll now show the inside and outside of my finished product. So, on top we have the label with the name, Hey Mycroft. The box is hard plastic, as mentioned before, completely coated black, so the inside cannot be seen like a real product. The lights are visible on the outside and are all clearly labeled. Here we have 3 and 4, and here we have lights 1 and 2. The microphone can also be seen coming out of the outside. This is what it's spoken into. There's also a hole for the power cord, which allows the system to work. And as you can see, a red light is on, meaning that the Pi is on and the system is working. Now open the box. As you can see, first we have the battery charger, which is housed inside the box. So if the battery is depleted, you can just easily plug the charger into the battery. This is a smart charger, so the battery cannot overcharge. If I take out the charger, we have the remaining circuitry for the product. First, we have the 12-volt battery, which is connected, completely bolted down, and connected to the soldered breadboard. This breadboard is connected to each of the 4 lights, which is also connected to the relay module. These 3, all connected to the breadboard, allow the system to work completely. As we see, we also have the Raspberry Pi connected to the relay module. The I/O ports for the Pi are connected to the input ports for the module. There's 1 cable for each of the 4 modules of the relay. The relay is also powered from the 5-volt port from the Pi and the ground port from the Pi, which power is once again coming from here. Finally, we have the USB microphone, which is connected directly to the USB port of the Pi, allowing the Pi to pick up noise from the microphone, which is then used for Mycroft. As you can see, the relay is completely bolted down along with the Pi being bolted down. This means that this system is completely secure and nothing can move around. Okay, so here we have the code used for the project. Up top, we can see all of the imports used here. The first 1, 2, 3, 4, 5, 6 imports are used from the OVOS, or the Open Voice software, which is now Mycroft. These are used to actually use the voice assistant, the voice recognition, and to interact with the Pi. The last import we have is the GPIO zeros. These are used to interact with the GPIOs of the Pi. Next, we have assigning the LEDs and initializing the pins. As we can see, we're initializing the 2nd, 3rd, 4th, and 17th pins, to each respective LED. These are standard GPIO pins on the Raspberry Pi. Next, we have the skills from the OpenVoice OS. These 5 functions allow the code to work with Mycroft. We have different classes and we have different decorators which allow the custom voice commands to be interpreted by the software. These were given to us by the software itself. Next, we have the actual code that I wrote for this project. As you can see, we have functions to turn on and off each LED. So we have a turn on light 1, turn on light 2, turn on light 3 and 4, and then turn off for lights 1, 2, 3, and 4. As we can see, we have decorators, which are then fed into intents. As you can see, the intent here is turn on light 1. This means that when the system hears turn on light 1, the decorator, which is at intent handler, will then tell the system, okay, we heard turn on light 1, so we're going to send the signal to the Pi, which then sends the signal from the pin assigned to light 1, which we did earlier, and that pin will then send the signal to the relay, which will turn on each light. This is done, of course, 8 times, 4 ons and 4 offs. I will now demonstrate the final functionality of this product. As stated before, the microphone is here, and the 4 lights are along the side of the box. The box is plugged in, well, the Raspberry Pi is, and you can see the light, meaning the system is on. Okay. Hey, Mycroft, turn on light 1. Hey, Mycroft, turn on light 2. As you can see, both lights 1 and 2 have turned on, meaning the microphone is picking up my voice and the system is working properly, ensuring the lights turn on. Hey, Mycroft, turn on light 3. Hey, Mycroft, turn on light 4. As you can see, lights 3 and 4 are now on. Inside, there should be 4 LEDs lit on the relay. I have demonstrated this in previous videos, and for the sake of keeping the product as one, I'll not show this now, but the relays have flicked all 4 lights on, meaning the system works as intended. I will now turn them all off. Hey, Mycroft, turn off light 1. Hey, Mycroft, turn off light 2. Hey, Mycroft, turn off light 3. Hey, Mycroft, turn off light 4. As you can see, all 4 lights are now off on the system, meaning the system works perfectly as needed. And just to confirm, the lights don't need to be put on in order. As you can see, I can say, hey, Mycroft, turn on light 2. And light 2 turns on. And vice versa, I can say, hey, Mycroft, turn off light 2. And light 2 turns off. This has been my final demonstration for my ECE 5000 project. Thank you very much, and I hope you enjoyed my product. Thank you.